Hey there, chemistry students. This is Miss Rulark. This is vodcast 5.6. We're going to learn how to write a net ionic equation and whatever a net ionic equation is, right? Okay, so when we're writing chemical equations, we can take a double replacement reaction or, well, pretty much any type, but anything that's going to be an aqueous solution, and we can divide it up into three different types of reactions or equations. We can have our molecular equation. A molecular equation is pretty much everything that you've seen so far. So this right here, this double replacement reaction where cadmium 2 nitrate with sodium sulfide gives you cadmium sulfide and sodium nitrate. It produces a salt or a solid, and so it's a double replacement reaction. That would be considered your molecular equation. That's something you're familiar with. We've been dealing with that for some time now. Another type that you can write is called a complete ionic equation. Okay? And a complete ionic equation shows everything that is aqueous is broken up or dissociated into the ions that make it up. Okay? Because when we take a substance, and I've said this before, but I'll go ahead and talk about it again. When we take a substance and we put it into water, when it dissolves in that water, it does not stay as cadmium nitrate. It breaks apart into cadmium ions and nitrate ions. It dissociates, and so you have these ions just floating around in the water. Okay? And actually what happens is that the polar ends of the water molecules, because you have HOH, remember this is going to be the slightly negative end, and this is going to be the slightly positive end, and so those slightly negative and slightly positive ends will surround the ions. So cadmium will be surrounded by a bunch of slightly negative oxygens, and then off of the oxygens you would have the hydrogens, which are surrounding this negative ion for the nitrate. Okay. Go back. And then the last one that you can write is called technical difficulties, sorry. All right, and then the last one would be called a net ionic equation, and that just shows only what's involved in making the final product. Okay, so the complete ionic equation. We can take this molecular equation and we can write the complete ionic equation. And we do this by showing all compounds that are aqueous are written as ions. So anything that has an AQ after it, we're going to break apart into ions. So cadmium and nitrate would break apart into the ions that make them up. Cadmium nitrate, right? And then they're not together anymore, so they're floating around, so they're dissociated, so we have to put a plus between them. And it's best if you go ahead and balance it as you go, so you don't have to worry about it later. Well, since there's 2 nitrates, we put a 2 here in front. Those are aqueous. All right, so then we plus sodium sulfide. It has an AQ after it, so we need to break this up. Well, we've got 2 sodium ions, and each one has a positive charge. And then we have a sulfide ion, and it has a -2 charge. Okay. This isn't too scary, I hope. Okay, this right here does not have an AQ after it, so guess what? It does not get broken up. We keep it like it is. And then this one, sodium nitrate, has an AQ after it. So we've got 2 sodium ions, and we've got 2 nitrate ions. And that's it. That was easy, right? Complete ionic equation. You take anything that has an AQ after it, and you break it apart into the ions that make it up. All right, well, the net ionic equation, we get that by taking our complete ionic equation and we cancel out all the terms or all the things that appear on both sides. Okay, so cadmium with a +2, and we look over here, and guess what? Cadmium with a +2 is not here, so we're going to keep it. All right, well, what about 2 nitrate ions with a -1? Look here, we have 2 nitrate ions with a -1, so we're going to cancel those out. We don't need them. Right? They're on both sides. We don't need them. 2 sodium ions. And guess what? We have 2 sodium ions on the other side, so we're going to cancel those out as well. All right, sulfide ion with a -2. No, it's not there. So after we've crossed out all the like terms, or the terms that appear on both sides, we rewrite whatever's left over. So cadmium with a +2 plus sulfur with a -2, and that gives us cadmium sulfide. And that is our net ionic equation. Pretty easy, right? Good. Okay, so your equations must be balanced. When you're doing your balance, you have to balance the materials. Make sure both sides of the equation have the same number of each type of atom. And then there also has to be an electrical balance and make sure that both sides of a reaction have the same net charge, which means that if one side has a zero charge, the other side has to have a zero charge. And if you have to add in electrons, add in electrons. Now, I'll show you what I mean if we get to one of those. All right, so here we have NaOH and MgCl2 and they're being mixed. Okay, so we've got NaOH, which is an aqueous substance, and it's mixing or reacting with magnesium chloride, which is an aqueous substance, and it's going to produce, look, it tells us a solid and sodium chloride. So we're going to make NaCl, NaCl, not NaCt. Let's try that again. Okay, there we go. All right, we're going to make NaCl, and we're going to make NaCl, Mg, and OH, so magnesium hydroxide. Why is there a 2 here? Because magnesium has a positive 2 charge. Hydroxide has a negative 1 charge. Don't forget that. Okay, we said that this is aqueous, and we said that this is a solid. And it says to write the balanced molecular, complete ionic, and net ionic equations. So we've got our molecular equation here. We just need to balance it. So let's go ahead and balance that so that we can finish this. All right, so 1 Na, 1 Na, 1 OH, 2 OHs. So we've got to put a 2 here, which then we have to put a 2 here. And now we're balanced. Yay! Okay, so balanced molecular. Complete ionic equation. We come through and we take anything that has an AQ after it and we break it apart. So this is going to break apart into 2 sodiums with a positive charge and 2 hydroxides with a negative charge. Okay, GCl2 is going to break apart into magnesium with a positive 2 and then 2 chlorines with a negative 1. And then NaCl gets broken into 2 sodiums with a positive charge and 2 chlorines with a negative charge. And then since magnesium hydroxide has an S after it, it stays together and it doesn't break apart. All right, and then the last part says to write the net ionic equation. Okay, so we can go through and we can cross out everything that's the same on both sides, cross out like terms. Okay, that's one way to do it. The other way that I like to do it is I look at it and I say, well, if this here is my product, it's my solid, I'm going to go ahead and write that here. And it doesn't always work this way, but sometimes it does. Okay, and then what makes that thing up? Well, magnesium and 2 hydroxides. Okay, and you get the same thing by crossing out the like terms. There you go. And it doesn't matter if the 2OH comes first and the Mg comes second, or if it's written this way. It's still the same thing. All right, not bad. Okay, so it says identify the spectator ions in the following complete ionic equation and then write the net ionic equation. So spectator ions, you know those things we've been crossing out on both sides? We call those spectator ions. Okay, so at anything where you have spectators, right, people who are watching, at a sports venue, you have spectators who sit back and watch the game. They cheer it on, but they don't actually participate. That's a spectator ion. It's there, it watches it happen, but it doesn't participate in the act of having that product be formed. Okay, so identify your spectator ions. Well, copper is on both sides and chlorine is on both sides. So our spectator ions would be copper with a positive 2 charge and 2 chlorines with a negative charge. And then our net ionic equation would be SO4 with a negative 2 plus barium with positive 2 gives us BaSO4 solid. All right, so now I want you to pause it. I want you to come back, try this next one, and then come back and check how you did. Okay, oops, I crossed out the wrong one. Let's do that again. All right, so we have nitrates on both sides. We have lithiums on both sides. Okay, so our spectator ions would be 3 nitrates and 3 lithiums. And our net ionic equation would be iron 3 ion and 3 hydroxide ions to give us FeOH 3 solid. All right, write the complete ionic equation, cancel out any spectator ions, then write the net ionic equation. So remember, anything that has an AQ after it, we have to break apart. So this would be not just 3, there would be 6 sodium ions plus 2 phosphate ions plus 3 calcium ions plus 6 chlorine ions, and that would give us calcium phosphate and 6 sodiums and 6 chlorines. Okay, so then what my net ionic equation would be the 2PO4. Oh, I left my charge off, sorry. With a -3 plus 3Ca2 plus, and on the other side we would have Ca3PO4 2 solid. All right, on this one we would have 4 sodium ions plus 2 sulfides, and then we would have 2 silvers, positive 1 charge, oh my goodness, and 2 acetate ions, and then we would have, oh, I didn't tell you which was which, did I? So now you gotta look at your solubility rules. All right, well, this one has a group 1 metal at the beginning of it, so it has to be aqueous. And this one is a sulfide and it has silver on it. It's almost like a double whammy, so it's a solid. All right, so we would have 2 sodium ions plus 2 acetate ions plus silver sulfide solid. Okay. Net ionic equation would be 2S with a -2 plus 2Ag. That is not right. It's not balanced. This is wrong. This should not be here. Kept wondering why. Okay, there we go. It should be 2 sodium ions plus 1 sulfur. Okay, so then this, yes, okay. Oh, much better. Much better. Sorry, it was really going to bother me. Ag2S with a solid. Okay, there we go. Okay, use the solubility rules to predict products and write the net ionic equation for the following reactions. Let's see how many we have. We only have 3. Okay. All right, so aluminum. Now, solubility rules, but this is a single replacement reaction, isn't it? Yes. Okay, so look at your activity series. All right, and you see that aluminum is going to try to replace hydrogen, and it will because it's higher on the list than hydrogen. So we would end up with hydrogen gas and aluminum sulfate. All right, I know it snuck in there from I don't know where. Okay, on this one, H is going to attach itself to the OH, and so H2O, and then barium is going to attach itself to the chloride for barium chloride. And then we look at our solubility rules and chlorides. It says chlorides, bromides, iodides, and fluorides are all insoluble unless it's attached to silver, mercury, or lead. So, barium chloride, what's it going to do? It's going to be aqueous. What's water? Well, water is actually going to be a liquid. So we could say that H plus OH gives H2O. I know it's not balanced. So, Mr. Rourke, you need to follow the rules. Go back and balance that equation. Okay, sorry. Put a 2 there. Put a 2 there. So we're going to put a 2 there, which means that we have to have 2 and 2. Or it could be a 1 and a 1. It's fine. It's all the same thing. Right? Right. Okay. On this last one, we have sodium phosphate. The sodium is going to attach itself to the Cl. And we know that table salt is aqueous. And then barium phosphate, Ba3PO42. And barium phosphate is going to be soluble, or solid, excuse me. So our net ionic equation is going to be barium, 3 of them, with a +2, plus 2 phosphates with a -3, gives us Ba3PO42. Solid. And that's it. Okay, guys, we're going to practice more when you get to class. I'll see you then.